Hello, Algebra 2 students. Today we will be doing 6.5 notes, graph square root and cube root functions. So I've talked about square root functions, I've talked about cube root functions, but you have no idea what they look like. But you do know what linear functions look like. You know that linear functions can be diagonal, horizontal, or vertical lines, and um, absolute value functions are V-shaped, quadratic functions are U-shaped, and now we have square root and cube root functions. So we will start with the parent functions. So in problem number 1, we have the parent function for the square root function for part A, and for B, it's the cube root function. So the easiest way to do these two problems is to make a simple table. And so what we want to do is make a table of values, and for the square root function, and you want to pick the smallest numbers possible. We pick like 3 to 4 numbers for x. And notice what I'm going to do. And we don't want to use a calculator for this. So you want to pick nice numbers that you can take the square root of. You don't want to pick 2 because the square root of 2 is some ugly decimal, and we don't want to use a calculator. And I hope you notice that I did not pick any negative numbers because you can't take the square root of negative numbers. So you have to stick to 0 and anything greater. And hopefully that'll make sense when we do the domain and range. But you don't want to do the domain and range until after you do your table. So the square root of 0 is 0. The square root of 1 is 1. And the square root of 4 is 2. And what I did was I replaced each of those x values right here and then took the square root of them. And so let's plot those 3 ordered pairs. So we have 0, 0, 1, 1, 4, 2. And this is what the graph looks like. It curves outwards, but it keeps getting bigger on the y side. And that is what your graph looks like. It never goes past the 0, 0. So this is like your starting point right here. And so now we can do the domain. Notice for the domain, we could only pick numbers. X could only be picked if it was greater than or equal to 0. So we could pick 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, anything. So we have to write it that way. I mean, you can write it in word form and just say 0 and larger, and that would work too. For range, your range are your y values. So if you look at these values, the smallest minimum number is 0. So y has to be at least 0 and larger. And that is your domain and range for the parent square root function. We will now do the cube root function. So making a table. Now, x can be positive or negative because cube root, it doesn't matter. The index is odd, so you can have a positive or negative answer. So you can pick -1. I'm going to pick -1, 0, and +1. Those are good enough for me. So the cube root of -1, what number multiplied by itself 3 times gives you -1? And it's -1. Cube root of 0 is 0. And the cube root of 1 is 1. So we are going to plot those 3 ordered pairs. So you have -1, -1, 0, 0, and 1, 1. Here's the problem. Most students think this is a straight line, but it's not going to be. So just for this particular problem only, I'm going to put in 8 here. And you're going to think, why did she go jump from +1 to 8? Here's why. You can take the cube root of 8. It's a really nice number. It's 2. Because 2 times 2 times 2 is 8. So if I were to graph that, here's 1, 2, 3, 4, 5. It'd be 8 over here. Here'd be the 2 somewhere. And this is what the graph would look like. And then it would be the same for the -2. I'm sorry, if I had picked -8, the graph would have been somewhere over here. And then, but this is what the graph looks like. It's like this sideways S. But it's not a straight line. Cube root functions are not, it's not going to be a straight line because it's not linear. For the domain, we could have picked any number for x, positive or negative. So our domain is going to be all real numbers. We weren't restricted to anything. Therefore, our range will give you positive and negative numbers as well. And that's the parent function for the cube root function. Now we'll do some other examples that are like your child functions. So problem number 2, we have 1/2 times the square root of x. So let's make a table of values. And again, we can only pick positive numbers for x because you can't take the square root of anything negative. So I'm going to pick the same 0, 1, and 4. The square root of 0 is 0 times 1/2 is 0. The square root of 1 is 1 times 1/2 is 1/2. And the square root of 4 is 2. 2 times 1/2 is 1. Remember, again, I just plugged all your x values there, but then I have to multiply by the half out there. So 0, 0, 1, comma, half, and then 4, comma, 1. And here is that function. Go crooked for some reason. Okay, the domain, look at your table. X is at least a minimum of 0, so x is greater than or equal to 0. Your range, y is the smallest possible number is 0, but anything bigger is always going to be positive. Or any of the other numbers is going to be positive. Now we'll answer the question, how does number 2 compare to 1a? How does this graph compare with its parent function? So compared to y equals square root of x, there is a vertical shrink. It's been shrunk by a factor of 2. By a factor of 1/2. So there is a vertical shrink by 1/2. What do I mean by that? The y values have been cut in half. If you look at the previous one, the y values were 0, 1, and 2. Now there's 0, 1/2, and 1. So y values are halved. There. Okay, and now let's do the cube root problem. So and I say we use the same numbers, and we could put 8 if we want. So this time let's do a few numbers, even though we're not going all the way up to 8. So I will do positive 8, but I won't do negative. So let's pick negative 1, 0, positive 1, and I'll throw in the 8 here again. Okay, this time we're going to take the cube root of each of those x values, but then we have to multiply by negative 3. So cube root of negative 1 is negative 1 times the negative 3 is 3. Cube root of 0, 0, 0 times anything. Okay. Cube root of 1 is 1, 1 times negative 3. Cube root of 8 is 2, and 2 times negative 3 is negative 6. Let's plot those. So negative 1, 3, 0, 0, 1, negative 3. And again, it's not going to be linear. So let's plot 8, negative 6. So 1, 2, 3, 4, 5. Somewhere over here. Somewhere down there. This is a good estimate of what it looks like. So yeah, there we go. And let's look at our domain. It's going to be all real numbers because x took on positive, negative numbers, and 0. And range is all real numbers. You're going to like this section for the most part because the domain and range for cube root functions are always going to be all real numbers. So that's really easy. Okay, now let's look at that. Let's look at that graph compared to 1b. How does that graph compare with its parent function? So first of all, I hope you notice that there has been a reflection because of that negative. So we are going to say compared to y equals cube root of x, there is a reflection over the x-axis and a vertical stretch by 3. So if you look at the table of values, the y values have been multiplied by 3, and there's been a reflection. So there you have those two child functions, and let's do 2 more. So this time we're going to see something different, and I don't know why this -2 is way down here, but we'll just deal with it. So let's make a table of values again. And this one is a little tricky. So we don't just pick 0, 1, and 4 because there's another number inside the square root with the x, and that's a +1. So here's what we do to figure out what numbers we want to put in our table. So what you want to do is you want to take this whole x plus 1, and you must set it greater than or equal to 0. Why greater than or equal to 0? Because you cannot take the square root of anything negative. So it can't be less than or equal to 0. It has to be 0 and larger. So then subtract 1 on both sides. X is greater than or equal to -1. And you know what the beauty of that is? That happens to be your domain. Oops. I want to make that the same nice color. So when you're picking numbers in your table, you have to start with -1 and anything larger than -1. So then I would pick another numbers that you can find the nice square root of. So you don't pick 1, but 0 would work. And the reason why 0 would work is if you go back here and replace x with 0, 0 plus 1 is 1, and the square root of 1 is a nice number. So, but you don't want to pick 1 in your table because 1 plus 1 is 2, or 2, but you can pick 3. And I think those are good enough. That's enough numbers in our table. So those are good numbers to pick for our particular table. Yep. And now let's find the y values. So -1 plus 1 is 0. The square root of 0 is 0. Oh, I forgot something. And then you have to subtract 2. So you do all the stuff in the square root and then subtract 2. So -1 plus 1 is 0. Square root of 0 is 0 minus 2. 0 plus 1 is 1. The square root of 1 is 1. 1 minus 2 is -1. 3 plus 1 is 4. The square root of 4 is 2. And 2 minus 2 is 0. So now we're going to plot those points. So -1, -2. 0, -1. And 3, 0. A square root function is basically half of a parabola, but sideways. So, but there's not both halves. Our range, look at your range values and look at the very top number. Our range, -2, -1, 0. So y is greater than or equal to -2. That's why for those, if there's a number inside with x, you can actually do the domain and range first. Or you could do the domain first, then wait and complete your table to find the range. And then let's go ahead and compare this to the parent function. If you compare it to 1a, notice it has been shifted left 1. So left 1 and then down 2. How do you know it went left 1? Because if you look at the table values, 0, then you have the -1. And then all we did was we subtracted each of the numbers in the x column by 1. And we got the x values. And then the y values, we just subtracted 2. And that's what happens. And let's do our last one. So making a table of values. we have to again pick nice numbers that we can take the cube root of. And so we want to come up with numbers that'll give us cube roots of 8, 8 or negative 8, 1 or negative 1, 0, and 1 or positive 1. So to get negative, but we don't want to pick something super large. The only way we can get negative 1 to appear in here is to make x equal to negative 5. Because negative 5 plus 4 is negative 1, and we know the cube root of negative 1 can be taken. Another good number is negative 4, because negative 4 plus 4 is 0, and you can take the cube root of 0. Another one is negative 3, because negative 3 plus 4 is 1, and you could do that. And then you can pick your positive numbers, or you could pick like 4. And I'm going to do that. So those are the 4 values I'm going to pick. Let's start with the very bottom number, 4. If you replace 4 back into your radical, 4 plus 4 is 8, and the cube root of 8 is 2, and then multiply by this 3. So 2 times 3 is 6, and then finally subtract 1. Okay, for negative 3 plus 4 is 1, cube root of 1 is 1, 1 times 3 is 3, 3 minus 1 is 2. This one's going to be 0. Oh, I'm sorry. The cube root, negative 4 plus 4 is 0. 0 times anything is 0, but then you have to subtract that 1. The kicker is this thing right here. You have to subtract by 1, so you're going to have something. And so negative 5 plus 4 is negative 1. Cube root of negative 1 is negative 1 times 3 is negative 3. Minus 1 is negative 4. Let's plot these. And you know that the domain and range are going to be all real numbers. Okay, so we have negative 5, negative 4. 1, 2, 3, 4, 5. Negative 4, negative 1. Negative 3, comma, 2. And 4, comma, 5. At least you know what it looks like. And then this way it goes. Hardest part's connecting everything. You know, how does this graph compare with its parent function? It has been shifted left 4 because each of your x values have been subtracted by 4, and then you've gone down 4. I'm sorry, down 1. I don't know why I put down 4. So. And then there's a vertical stretch. We'll summarize this on the back page. Right, now going to the back page. For the parent functions y equals the square root of x and y equals cube root of x, the following changes occur. So we're summarizing everything we learned on the first page on the back page. So these are the parent functions. So I'm going to write that over here. So parent, square root, and parent, cube root. What happens if there's a number inside with the x for either one, and then a number outside on the right side? So what happens if there's that number h, and hopefully you remember this, h comma k is super duper important when we're talking about our graphs. So if there's a number h, if there's a number k, there is stuff that happens. So h tells you whether there's a right or left movement. K tells you up or down. And h is always opposite of what it shows in the equation. A tells you if it's reflection. So A is reflection. So same thing for if it's a cubic function. So right or left, up or down, reflection. And stretch. And stretch or shrink. So without even graphing, we can tell so much about what's the graph looks like. So let's look at number 6. So the parent function, y equals square root of x, is translated to y equals square root of x minus 5 plus 4. What translation took place? So here, this says it's negative 5. That doesn't mean it's moving left 5, because remember, it's opposite. It means you move right 5 and then up 4. K does not change, so keep K. You know what? That's a good thing to write here. Keep K. Good way to remember it. And there's been no vertical stretch or shrink because there's only a 1 in front of the square root sign. Okay, so that's it. Number 7, if the cube root function is translated so that you have x plus h minus k, what translation took place? So if it's a plus k, you actually move left. So you move left. Here, h can be anything. So left h units, and then down k units, because k doesn't change. Okay. Number 8. Oh, wow. This didn't print. So there should be a square root of x there. So please go ahead and put that in there. What translation took place? What transformation took place? Well, there is no right or left movement or up or down because all you have is x inside the square root. So there is this that tells us a lot, and that means it's a vertical stretch. How do you know if it's a stretch or a shrink? So if it's bigger than 1 and disregarding the sign, because the sign doesn't matter whether it's negative or positive. So it's a stretch if it's anything bigger than 1 regardless of the sign. So vertical stretch by a factor of 3, and be a shrink if it'd be something like 1/2 or 1/3 or 1/7, anything less than 1, or negative 1/2 or negative 1/7. So vertical stretch and a reflection because it's negative over the x-axis. Now, do you need to put vertical stretch by 3? You can if you want to, but you don't need to. And our last one, if the cube root function is transformed to y equals 1/3 times the cube root of x, what transformation took place? So here I kind of gave it away. So notice this is the exact same as that. So there's no right or left movement or up or down movement. The only movement is that 1/3. So the 1/3, seeing it's less than 1, that's a vertical shrink. So all the y values would be shrunk by 1/3. And those are your notes for today. Have a great day, Algebra 2 students.